Welcome to the Picky React Conversations with our experts, your decryption key to the future of cryptography. In this series, we dive into one of the most critical transitions of our digital age, the shift from classical to post-quantum cryptography. As quantum computing rapidly evolves, so does the urgency to secure our digital systems. My name is Marva Rabadzi, and I'm one of the communication and dissemination managers of the Picky React project. Today, in our fourth episode, Securing Tomorrow Networks, Quantum Key Distribution and Post-Quantum Cryptography and the 5G Transition, we welcome Victor Hernandez from TELEFONICA. Victor is a research engineer who has been working at TELEFONICA since 2024. His research focuses on the field of post-quantum cryptography. So, without further ado, let's start. Hello, Victor, and thank you for being with us today.
Hello, Marva. Thank you for letting me explain a little bit of the work that we do in the project pilots.
Okay, let's start with the first question. As the leader of the work that focuses on the execution of the project's pilots, can you walk us through the three pilot use cases of Picky React, what they are, what they aim to achieve, and how they will demonstrate the project's broader objectives for transition to post-quantum cryptography?
So, sure, I can explain you a little bit. As you mentioned, the goal of the pilots is to evaluate the transition to post-quantum cryptography. So each pilot is focusing on a specific scenario. The first pilot is working on firmware updates in smart meters. Thanks to this pilot, we will be able to assess the impact that the transition to post-quantum cryptography may have on systems with limited resources, both in terms of memory and computing capacity. The second pilot focuses on studying how to secure 5G connections. With this pilot, we will gain insight on how post-quantum transition affects telecommunication networks and will allow us to study how post-quantum cryptography behaves in highly scalable environments. Then, the third pilot focuses on enable secure end-to-end customized connectivity service across multiple domains, and it's helping us in understanding the implications of the use of post-quantum crypto in a multi-domain environments and how to assure trust across domain boundaries.
Okay, thank you for analyzing and explaining the project pilots. Let's now move to one of the Picky React's big challenges, which is the coexistence of quantum key distribution and post-quantum cryptography. What's the rationale for including this challenge in the project?
So in the context of this project and the development of these pilots, we found it particularly interesting to work with these two types of quantum-safe solutions. We are interested in seeing how they can complement each other within the scenarios that we are developing, so that we can understand how they work together or when it's more useful to use one or another depending on the needs of each case.
Okay, so since we have talked about the project pilot use cases and challenges, can you give us the context of the quantum key distribution on 5G networks pilot? What is its aim, what outcomes do you expect, and what could be the real-world implications?
Our goal here is to evaluate the behavior of QKD in 5G networks. The idea is to create a secure communication channel between the radio stations and the core of the network, so that communications between them, what is called backhaul, are encrypted using keys provided by the QKD system. We want to assess the performance difference between this solution and the current one, which relies heavily on classical cryptography. In terms of real-world implications, a solution like this should be useful in encrypting communications in premises that require a high level of security, such as government buildings.
Okay, thank you very much. And let's move to the fourth question. From the perspective of a project that has in its name the reaction to quantum threats, what is the uptake of the solutions you are addressing in production networks?
So we are currently focused on evaluating QKD as a commercially available technology to secure both our clients' traffic and our own infrastructure. At the same time, we are also looking at how to progressively integrate PQC into production 5G networks, aligning its adoption with the pace at which this technology are becoming available and standardized.
Okay, thank you very much, Victor, for sharing all these fascinating insights. We could easily talk for hours, but I think it's time to close this episode. In the next one, we will dive into more topics and explore new themes around the post-quantum world. Stay tuned with the Picky React project and follow our journey on our social media platforms.